Okay, so today we've got Francisco, who's applied some of our TensorFlow JS models to the world of sports. First though, as always, tell us some more about who you are and your background with machine learning.
Sure. Hi, Jason. Thanks for having me first. I'm Francisco, the CEO of TeamSports, AI sports performance platform. I'm based in London. You probably can tell by my accent. And my experience with TensorFlow and machine learning goes back 2 years and a half ago or so, starting with YOLO initially, and then settling with TensorFlow to deploy our sports platform.
Awesome, that sounds really cool. And what exactly is it that you've made?
Sure. I'm an avid athlete and a basketball player myself.
Hmm.
And what we created was a sports platform that helped teams, amateur teams such as myself, to access sports performance data and statistically easily and affordably. So we created a platform that enables both coaches and players to use artificial intelligence and TensorFlow models to generate the performance statistics they need to understand why are they winning games or not winning games, and how can they improve their performance, whether it's from a conditioning or from a skills perspective. And that is, in a nutshell, is Team Sports.
Very cool. That sounds very useful. So I believe it's time for a demo. Can you walk us through it?
Sure. Cool. So what you're seeing over here is a library of exercises. So any coach has the ability to access Team Sports platform, upload their videos, configure the videos to cater for the needs of their players. So the level, the number of reps, and some of the standard configurations for an exercise. In this case here is a conditioning exercise, and they can simply upload the video and publish to the web. But the clever part here is what you're seeing is our editor that enables us to detect performance stats, in this case reps. You can see the girl doing the lunges over there, and you can see nothing is happening. It's not being counted. But we created an algorithm that sits on top of TensorFlow models that enables us to say, hold on, what are we tracking over here? What limbs are important for this exercise? And how can we create a sequence of positions that then enable us to track? And so what you're going to see here is me defining how do I want to track one of the legs. In this case, it's the right leg. So I'm adding the leg in two separate positions. And what this will enable us to do is to understand what the exercise or what the girl is doing with the leg.
You can pause the video basically any way you wish to kind of capture that moment as a keyframe, if you will.
Exactly.
Yeah. Okay.
And I think this is the most of the basics examples, but you can take this to any level. You could track a completely new, this is only for SEAL sort of exercise,
Yeah.
where you can come up with all sorts of combinations of aspects that you want to track, or a combination of movements or sequence that you want to track. And it becomes a very powerful tool.
Yeah.
And this is available to everyone, and to any coach. Any amateur coach could come here and create a custom exercise, or use or leverage their existing exercise. They don't need to create a custom one, but it's as easy as you're seeing over here. And now, with a few clicks, we can track the movements of both legs, and there is a performance stat. You can publish that
Yeah.
exercise, and as simple as that.
I love how easy you've made it to
Yeah.
actually capture the key points and add data to the system. So I guess if you have a video where there might be slight variations to the pose, you can add like multiple examples of the key points.
Yeah, so what I think, so there's like two layers here. So what we're doing is sort of using the MoveNet. We started actually with PoseNet initially, and we talked about a little bit about that. But with MoveNet, effectively what we're doing is sort of, okay, now that we can track a human body, what can we understand of this movement? So we wanted to create an algorithm that was slightly independent from the machine learning. So we're not training a model to detect push-ups and squats, or a basketball drill for that matter. And that enables us to not rely so much on AI, because remember, we're deploying this into a mobile app with limited resources, and not everyone has a Google Pixel 6, which is not out yet, so no one would have that. But no one might not have the latest phone, and therefore, because of the limited resource on the phone, we want to limit the number of models that are currently running, and is our algorithm on top of it, and sort of as simple as you saw, our position editor that enables us to say, okay, so what sort of movements are happening here, and what we know of this movement, and now that we can create a configuration of the movements that we're trying to track, let's count them, and that creates the reps, and that creates the 1 push-up, 2 push-ups, 3 push-ups.
So it'll allow for some variation, but if my leg's in a slightly different kind of angle or something like this. Okay, cool.
Indeed. So you probably have noticed that it's also, so we've got some tolerances. So it's not just, the tolerance will enable us also to deploy exercises for youth. So if you get a 12-year-old to try to do a good squat, they're probably not going to be in the right form. And that enables us to say, actually, this is for kids. Let's add a little bit more tolerances.
I see. Okay,
you can customize. Or this is for a semi-pro. Let's reduce the tolerance because they should know how to do this stuff, that sort of thing.
Sure. Yeah, okay, that sounds good. Now, you mentioned you're using MoveNet there, which is our latest pose estimation model.
Indeed.
How easy was that to actually integrate into your product?
Once you get around of sort of the new abstraction layer and then sort of the API, the sort of effectively decouple the model from the rest, I think was fairly easy. It took us 3 to 4 days to get it up and running. So and I really like the beauty that now with this abstraction, so we can replace MoveNet with any other model and not having to touch our code, and that is beautiful. That's how it should be done.
So that sounds really cool. So what did this experience look like for the end user?
We created a very simple experience for our users. So whether you're a basketball player, a football player, you can simply prop your phone anywhere on a small tripod or even against the wall. The phone will detect you and the exercise will start. And that's it. The magic will happen. We'll count your performance stats, how many reps you're doing, whether they are push-ups or a ball control exercise. At the end of it, you get a lovely stats. You can see your dashboard, your performance. You can filter and see what you've done in the past. Also, you can see what our teammates are doing because it's good to see what everyone else is doing. But the experience for the user, it is very simple, and it feels more like magic and less like AI.
And I've also got to ask at this point, I guess, what would be on your wish list of other types of models that you might want to explore in the future? Maybe some of our viewers might actually be able to help bring those to life for sharing in the community in TensorFlow JS. Any thoughts?
My wish list is so long, Jason. I'm not sure we've got enough time, but I guess there's two sides of it. So being able to track multi-pose, so more than one person. If you think on the world of sports, you're doing a drill, you're probably doing a drill with someone else. So being able to capture two separate people, that would be fantastic. We have a use case tomorrow for that model, but beyond that, we'll also be able to track things like a ball. So a lot of the exercise and drills, we'll be using a ball. So a ball control exercise, for example, it is about how you control and is the ball in your hands or not. So being able to track sports balls. So let's not exclude American football balls, which are not round, or rugby balls, which are not round. But being able to track the ball or any other sports equipment, maybe a weightlifting, a dumbbell, or etc. Those will be fantastic. So we could deploy that in the next couple of days, and it will be our users will be loving to use that.
Excellent. Well, I've got some good news for you there and for our viewers, actually. Our MoveNet model will actually be supporting multi-pose very, very soon. So look out for that update coming. And I'm sure some people from our community will be able to make some kind of ball detection model using some kind of multi-box detection. I think one of our community members, Hugo, actually made a great tutorial on how to do multi-box detection for custom objects. So if anyone wants to give that a go and share it with Francisco, that could be a fun side project for someone. So good stuff.
Awesome.
All right. So for any of you watching, if you think you can help Francisco out, do reach out or drop a comment in the message box below. And on the subject of reaching out, how can people try this for themselves?
It's very simple. We've got a website. It's TeamSports.Pro, sports with a Z. We've got an Android and iOS app. They're out there. Please download the apps and try it yourselves. We love feedback, whether it's within the app feedback, direct feedback. Any feedback, we give us some feedback, and yeah, do use our apps. They're available to you to use, and we've got some cool features just out, Jason, if you allow me to, which is if you download the app now, you can challenge your teammates. So I could do some push-ups and challenge you, Jason, and then you get a lovely notification, and then you have to take the challenge. I'll get a medal, or you get a medal. So
okay, very good for these times where we're all at home.
Exactly.
A good chance to challenge your friends,
yeah.
and see who wins. And I think most people watching will beat me. So, but thank you very much for being on the show today. It's great to hear from you.
Thank you for having me. Thank you.